So now, like I said earlier, we're going to talk about the rule for how to identify if a value is actually an outlier rather than just looking at a graph. It's a really simple rule. It's 1.5 times the IQR, and I'll explain what that is here. So to find the IQR, which stands for the interquartile range, you have to find the first quarter and the third quarter. You've already figured out how to find the second quarter. That's the median. It's the middle 50. So the first quartile, which we're going to call Q1, and the third quartile we call Q3. It's the middle of the first half of the data, and this is the middle of the second half of the data. So first you have to arrange them in order again from smallest to largest. Then you have to find the median. Then you can find the median of the first half, and then you can find the median of the second half. And the distance from Q1 to Q3 is what we call the interquartile range, or the IQR. So the IQR is a distance or a measure of spread, which is just Q3 minus Q1. So it's actually a measure of, it's actually a range. And this is the middle 50% of a data set. So let's look at the same data set that I have here. And we've already found the median to be the average of 14 and 15. And so what we want to do is we want to find the middle of this first half, and then we'll find the middle of the second half. So Q1 is going to be the middle of these 1, 2, 3, 4, 5, 6 values. So if there's 6 values there, then I know it's going to be the average because it's an even number. And then Q3 is going to be the average of these 2 values. And you can always double check to make sure. I've got 2 here, I've got 1, 2 below, 1, 2 above. 2 here, I've got 1, 2 below, and 1, 2 above. So Q1 is going to be 13.5 for the visual group. Q3 is going to be 16.5 for the visual group. Now I can calculate my IQR. IQR is 16.5 minus 13.5. And the IQR is a total of 3. Let's find the IQR for the listening group. So we knew that the median was 13, the very middle number, or Q2 really is the median. Now let's find the middle of the first half, which there are 5 numbers there. So I will have 10 is the middle. There's 2 above and 2 below. So Q1 is going to be 10 for the first quartile. And the third quartile will be 14. There's 2 below and 2 above, just to make sure it's the middle. So Q3 will be 14. And the IQR is just going to be Q3 minus Q1, which will be 4. So the IQR is a measure of spread, and you can see the middle 50% of this data set is between 14 and 10, and it has a spread of 4, or a range of 4. So technically the listening group is a little bit more spread out, but not much than the visual group. There's more variation. But they're very similar, just slightly more. So once we found the IQR, then we can use our 1.5 times the IQR rule to identify if there are any outliers. So we're going to multiply this value 4 times 1.5 and add it to Q1, or I'm sorry, subtract it from Q1. So we'll go down this far, and then we're going to add it to Q3. Anything outside of those 2 values will be counted as outliers. So we call those the lower cutoff or the upper cutoff. You might see them called the lower bound and the upper bound. So to identify if they're outliers, let's first find 1.5 times the IQR. So the IQR for the visual data set was 3. So 1.5 times 3 is 4.5. And We're going to subtract that from Q1. So Q1 was 13.5 minus 4.5. That will be 9, and that is our lower cutoff. So anything less than 9 is counted as an outlier. 16.5 is Q3, and we're going to add 4.5. So that's going to be 21, and that is our upper cutoff. So are there any outliers? Are there any values less than 9? Yes, 6 is an outlier. And then are there any values greater than 21? No, there's not. So 6 is a low outlier is what we call it. So there is one outlier in this data set. Let's see if there are any in the visual or in the listening group. Cutoff. So anything less than 4 or greater than 20 is an outlier. And you can see 6 is our smallest, 18 is our largest. So there are no outliers here. No outliers in that group. So the last thing I want to look at is really making a graph of what we've done so far. And it comes from what we call the 5-number summary. 5-number summary is so easy to remember. It's the smallest value, which we call the minimum. It's Q1, which you know how to find. It's the median, which you know how to find. It's Q3, which you know how to find, and then the maximum. So min and max are the only 2 numbers that you need to know how to find, and they're just the smallest and the largest values. So let's look at the visual group and write the 5-number summary. 6 was the smallest value. Q1 we found was 13.5. Median was 14.5. Q3 was 16.5. Max 18 was the largest value. I'll fill in these values for the listening group. So we have the 5-number summary for both data sets. And the last thing we need to do is turn it into a graph, and we're going to call this a box plot. Here are a couple notes about how to make a box plot. I'm going to go ahead and draw the graph out and then talk about it because it will be easier for you to understand it after it's drawn. Okay, so I've completed the box plots, and just so we can talk about what these box plots are, you can disregard these 2 right here. I'm going to talk about those in a second, but the box plot is just a visual of the 5-number summary. So if you look at the listeners group, look at the data up here, the listeners, 6, 10, 13, 14, 18. You can see the minimum is 6, Q1 is the lower of the box, 10. Median is the line down the middle at 13. 14 is Q3. And then 18 is the maximum. And since we had one low outlier for the visual group, if you remember, 6 was an outlier after we used the 1.5 times IQR rule. This one is set apart. And you're going to draw the whisker to the smallest value that is not an outlier. So since 6 is an outlier, we're not drawing it to the outlier. We draw it to the smallest value that is not an outlier. So if we look back at the data set, you can see 10 is the smallest value that's not an outlier. So that's why we've drawn the whisker to 10 and not to 6. And then Q1, we can see, is at 13.5. So that's why our line's at 13.5. Median is at 14.5. Q3 is at 16.5, and the maximum is 18. We didn't have any high outliers, so we don't need to draw any outliers above. I drew these 2 boxes up here just as examples of shape. This first box here, we would call skewed right, because we have this tail being stretched out to the right. These high outliers, there's data going off to the right. Another sign of skewness is if you look at this IQR, which is the middle 50% here, there's more space on the right side. This median is to the left, which means it's going to be skewed to the right. So the location of the median helps determine if it's skewed. And then this box plot here is an example of one that is skewed to the left. And so what I want you to learn from this is the whiskers actually help you to see a direction of skew if there is any. Since this tail is stretched out longer, that's one sign that it could be skewed left. Since the median is over to the right and there's a long tail stretching out in the IQR, that's another sign of it being skewed to the left. So this is an example of being skewed left. If it were symmetric, it would look something like this. This is an example of a roughly symmetric. The median's in the middle. The distance from this tail is the same or similar to this tail. Another way you can look for skewness is the distance from the median to the maximum. So if you look here, distance from here to here is a lot shorter than here to here. And then look here, this one's skewed right. The distance from the median to the highest is a lot larger than the median to the lowest. So those are all the signs of skewness that you could see in a box plot. So the last question is to compare these two distributions. So I'm going to write out my comparison and then I'm going to talk you through important words to use and certain things that you need to look for when you're comparing two box plots. Okay, so I've compared SOX, which is shape, outliers, center, and spread. I want you to make sure you're used to seeing typically. So compare the centers. Which one tends to be higher, is typically higher? The visualizers remembered more because their median was higher. So now you have a measure of center. Your measure is median. Compare their medians. This one is obviously higher, so they typically remembered more in this group. The listeners group appeared skewed left. That's the shape. I said listeners were skewed left because you can see the distance from the median to the lowest value is further than the distance from the median to the highest value. So it appears skewed left. Sometimes it's going to depend on your drawing. So I will be lenient on your description as long as it matches your graph. And the visual group appears roughly symmetric with a low outlier. This one's kind of tougher because the median is pulled left, but this whisker is stretched out longer and there is an outlier. So the distance from the median to the lowest is actually a little bit longer than it is from the median to the higher. So this one's a little bit trickier to describe. I went ahead and said roughly symmetric because that's the way I would imagine a dot plot would look if I were to make it. So shape and center I've said. So I've also mentioned that there's a low outlier. There is similar variation in each group because they have equal ranges of 12. If you look, it's 18 to 6 and it's 18 to 6, same range. And they also have similar IQRs. If you remember, one had an IQR of 3 and one had an IQR of 4, so they're very close. But the key to remember is they have similar variation. Spread is talking about how consistent or how varied they are. So when we're comparing two distributions, those are two important words that I expect to see, something about which one tends to be higher and which one is more spread out or which one has more variation. So usually you learn in this video and go ahead and try this independent practice problem. And I will see you in the next video.